Hello and welcome in the class where we will understand the differences of artificial intelligence, machine learning and deep learning and their basic concepts. Artificial learning, it's a broader perspective of machine learning, and this machine learning is a subset of artificial intelligence and deep learning is a subset of machine learning. Artificial intelligence, it enables machines to think without any human interventions, where we can evaluate the intelligence of machines, intelligence demonstrated by machines. We have AI in today's world. AI is everywhere. We have it in e-commerce, chatbots, AI applications like self-driven cars. Now, machine learning, it provides us statistical tools to explore the data and understand and analyze in different way. This machine learning data, it can be analyzed to build smart systems and has different approaches. The first approach is supervised learning. Supervised learning, it's also called as labeled learning, where we know the output. Now, supervised learning, it can be in easy words, it can be understood as a procedure where someone is supervising us. For example, a teacher supervises students. Like a teacher provides some sort of training to make the students learn. So, in the supervised learning, a training is provided to the machine learning models to generate an output of a related category. So, supervised learning is applicable for classification and regression. And let's consider a dataset, IrisFlower dataset. You can download it from the machine learning repository. It's a supervised data set where the model, when we train our machine learning model, it will tell us it has different categories of flowers, versicolor, virginica and setosa. Output, the model will classify which flowers are versicolor, which are virginica and setosa. Now, the other category of machine learning is unsupervised learning. Now, clean and perfect label data sets, they are not so easy to have, and in this unsupervised learning, we do not have any data sets with explicit instructions on what to do, how to do. There's no supervision, there's no intervention of any person. We do not provide them any sort of output. Now, how the models learn is that they automatically find structures based on similarities of the data which is being grouped together. And how unsupervised learning is done by, it's done by clustering, association and autoencoders. And the third category of machine learning is reinforcement learning. Reinforcement learning, it's a semi-supervised learning. It's a middle ground between this supervised and unsupervised learning. In supervised learning, in reinforcement learning, the data sets are both labeled and unlabeled data. It's useful for extraction of relevant features from the data which is difficult. For example, it has high amplification application in medical images, MRI, CT scans, and video gaming is a very good testing environment for reinforcement learning. Now, how this reinforcement learning is helpful in medical research is because it contains both labeled and unlabeled data. And this small amount of labeled data, it can lead to the improvement in accuracy. Very good accuracy can be achieved when we have a small amount of labeled data. Now, deep learning, it's a subset of machine learning and it's inspired by the structure of human brain. Basically, the idea is to mimic human brain. It includes statistics, calculus, linear algebra. Now, building a hierarchy in which each level of abstraction is created with knowledge that was gained from preceding layer of hierarchy. That's feature extraction. A toddler learns to identify cat. Now, what does this mean? It sounds not so clear. For example, if a toddler learns what a cat is, but not by pointing towards that object, just it learns what a cat is. Now slowly, when the toddler continues to point to the objects, he gets more aware of the features of this cat, and slowly it tries to learn the other functionalities of this object. This is the abstraction. This is the abstraction function of deep learning. It tends to add more and more layers. Now, how these abstractions are being evaluated? Deep learning tends to add more and more number of layers. The more layers are added, the more abstract features and the better feature extraction of objects is possible. Now, we have talked about this deep learning, machine learning, and AI in a very generic way. Now, how is this applied in today's world? How is it practically applicable? It is applicable by the use of data science. Now, what data science is? Data science it's a practical application of machine learning with a complete focus on solving real-world problems. It applies this AI, machine learning, deep learning with the help of calculus, with the help of mathematics, probability, stat, and linear algebra. We have systems like recommendation systems. These are the applications of this, how data science is being used. Now, depending upon the types of problems, we have deep learning is further categorized into different models. First, we have ANN, which is artificial neural network. It's required where the problem it's based on solving numbers. And second one is CNN, required for problems where the input is in the form of image. ANN have numbers and CNN have input as image. Third one is recurrent neural network, where the input is in terms of time series data. Fourth one is autoencoders. Autoencoders, they compress input data to recreate it from a summarized code. This input data is compressed into a code which is then recreated from it. Then we have the advanced models of like transfer learning, recurrent CNNs, and many more, or Boltzmann machines. It depends upon the complexity of a problem. These models are being used. The more complex the model gets, the more complex the problem gets, the more complex and the more layers of the more hidden layers are being added in our network.